Hi there guys, welcome to question 4, and we're given this equation for y and we've got to find its maximum turning point. Okay, so you should know a turning point happens when, at this point here, when dy by dx is going to be equal to 0. Thus we're going to have to find the turning point, so we might, in this process, differentiate, might find a few more. But a maximum is when the gradient is actually decreasing. So when we come up to our stationary point, it's then going to be negative, it's therefore going to be decreasing. And we're going to talk about two ways of testing these. Okay, so let's find dy by dx. So that's going to be 3x squared minus 12x plus 9. Okay, and I've just told you that's going to be equal to 0 to find the stationary point. So let's do that too. Okay, I like these ones because I can already see that everything I'm writing now is a multiple of 3. So let's divide everything by 3. It's going to make your life so much easier. Now we have to factorize this, and by dividing it, it's made this number perfect as prime. It's only got two options. So we can do this one really quickly. So it's going to be x minus 3 and x minus 1. So therefore, we know that x is 3 and x is 1. And we get a turning point basically at these two coordinates. Now we've got to find out what the y coordinates are. So let's write this here. So when x is 3, we've got y is 3 cubed minus 6 lots of 3 squared plus 9 lots of 3. Okay, so that's 27. Take away 54 plus 27. Well, that's 0. Okay, so we've got our first coordinate here, 3, 0. And similarly, when x is 1, y is going to equal 1 cubed minus 6 lots of 1 squared plus 9 lots of 1. Oops, didn't mean to put a bracket in there, just scribble that out. So that's going to be 1, take away 6 plus 9. Well, that's going to be 4. So we get 1, 4. Okay, so we've got to work out which of these is the maximum, okay, using the information I told you earlier. So you've got a couple of options. Let's do option number 1. So option 1, we're going to draw a table. So here we're saying x is 3. And we know we've got to inspect the gradient to see what type of turning point it is. Okay. So we're going to go either side, so we're going to go to 2, and we're going to go to 4. Okay, so we know 3, dy by dx is equal to 0, so therefore it's flat. So let's pop a 2 in here. So when x is 2, let's pop this in here. So when x is 2, we've got 3 lots of 2 squared minus 12 lots of 2 plus 9. You don't actually have to work this out. You can do it by estimating, but we're going to go so far and then talk a bit, like skip a few steps. So that's going to be 4, and that's going to be 12. So 12 take away 24 plus 9. So that's going to be minus 12 plus 9. I know that's going to be minus 3. Sometimes it's a bit harder. So it's going to be negative, which means negative lines go like this. So at this point I could stop and say, well, this is not going to be a maximum because the best case scenario, this one can be positive and therefore it's the minimum. So I could stop. But I'm not going to. I'm very thorough. I like to make sure I do it properly. So when x is 4, we can have the same problem. So we've got 3 lots of 4 squared minus 12 lots of 4 plus 9. Okay, so that's 16 threes, 48, minus 48, plus 9, well that's going to equal 9, so that's therefore positive, and positive lines are like that. Okay, so you can see that this is a minimum. Okay, this is a minimum point. So this option's fine. Because I want to keep the video relatively short, I'm going to show you option 2 for the other one. But I could have done the same method for both points. But I'm going to do the second derivative method. So d2y by dx squared. So what I've got to do is differentiate this again. So I'm going to get 6x minus 12. Excuse me. So we've done this one. We know this one's a minimum. So this is the one we're going to look at now. So when x is 1, d2y by dx squared, that's going to be equal to 6 lots of 1 minus 12. 6 take away 12, it's minus 6, and minus 6 is less than 0. So that means it's actually decreasing. It's decreasing, and therefore a maximum point. What I was talking about earlier, once we go past, the gradient is decreasing. This allows us to prove that using this option, and we get a maximum. I'll go back to this. If you did do this method, you would have found your first one to be positive, the line going, say, like this. We've got that one in the middle, and then this would have been 0, this would have been 1. If you did 2, you would have had a line like that, and therefore you can see it's a maximum. Okay, all done.